Southern Launch's Koonibba facility sees AT01 fly. We deep dived into bringing James Webb into focus and how traffic vibrations saved a ton of research money. This is a wrap of the past 5 Talkin Science Daily Bites. At the end of last month, Brisbane-based rocket manufacturer ATSpace entered the rocketry record books by successfully launching their Australian-made A01 rocket higher than any other Australian commercial rocket has gone before. The A01 mission was the inaugural launch attempt of ATSpace's A01 rocket and marks an incredible step forward as ATSpace continues to develop their innovative hybrid rocket engines here in Australia. The launch was conducted from the Koonibba test range developed by Southern Launch in partnership with the Koonibba Community Aboriginal Corporation.
The area, the cover is large enough. And also the most important thing is it can help us to recover the vehicle after the experience. That will help us a lot to verify the things, the components after the experimental launch.
This is one of many planned launches by ATSpace as they develop their technologies as they grow to becoming an orbit-capable rocket launching company.
Go ATSpace. Evidence of lightning on Mars detected in sounds and electrical signals captured by NASA's Perseverance rover is presented in a paper published in Nature. The observations indicate that Mars's atmosphere is electrically active, informing our understanding of the planet's atmospheric chemistry and may have implications for future exploration. In our solar system, lightning and electrical activity occur on Earth, Saturn and Jupiter as far as we know, and while the existence of electrical activity on Mars has been theorised, it's never been directly demonstrated. The theories are strengthened by Mars's dusty surface, frequently hosting a range of localised and planet-wide events, including wind-blown dust and sand, dust storms and dust devils, which we know cause electrification here on Earth. By identifying interference and acoustic signatures that are characteristic of lightning, Baptiste Chide and colleagues categorised 55 electrical events. They found that all but one of the events occurred within the top 30% of the strongest wind events recorded during the study period, indicating that wind plays a crucial role in initiating electrical charge on Mars. 16 events were also recorded during the rover's only 2 close encounters with dust devils, highlighting the possibility that more distant or low-energy discharges could have also taken place beyond the microphone's range. These observations suggest that Mars's atmosphere is electrically active, particularly during localised dust lifting rather than globally dusty seasons. The authors note that such activity could enhance oxidising conditions affecting organic preservation and habitability, and may pose risks to equipment and astronauts. Scientists from the Australian National University have analysed signals generated by the vibrations of traffic along the Federal Highway to learn more about the seismic nature of Lake George, situated northeast of Canberra. According to the researchers, the study provides unprecedented insights into the structural characteristics of the Lake George fault zone, which runs along the western boundary of the lake. They say the fault holds clues about past earthquakes in the area. Using a network of 100 beer can-sized seismometers placed in the then dry lake bed and near the highway, the researchers analysed traffic vibrations and used that data to create 3D images, allowing them to peer 800 metres beneath Earth's surface, similar to doing a CT scan to create detailed medical images of the human body. According to study co-author Professor Megan Miller, traditional methods to study fault zones are difficult and can be very expensive, often requiring artificial explosions. She said the imaging technique of analysing ordinary traffic noise to study fault zones offers an innovative, powerful and non-invasive solution that can be used to conduct seismic hazard assessments in major metropolitan areas or regions that are difficult to access. The researchers collected data from the signals generated generated by passing traffic along the Federal Highway for about 4 weeks from December 2020 to January 2021, with the research published in the journal Seismological Research Letters. An astronomical instrument featuring Australian-built technology has achieved first light, the crucial moment when a telescope captures its first images at the European Southern Observatory in Chile. The foremost, or the 4-metre multi-object spectroscopic telescope facility, uses an optical fibre positioning system built by Macquarie University's Australian Astronomical Optics, allowing the telescope to simultaneously observe thousands of celestial objects, from stars and planets to nebulae and black holes. At the heart of foremost sits ESO, the Australian-European Southern Observatory Positioner, the robotic fibre positioning system designed and built by AAO. ESO can position 2,438 optical fibres with 10 micron accuracy. That's about 0.01 millimetres, or 1/7 the width of a human hair, in under 1 minute. Each fibre captures light from a different star, galaxy, or other celestial object, feeding it to spectrographs that analyse the light in detail. Key team members involved in the historic installation include Helen McGregor, AAO's Mechanical Group Manager, and Scott Smedley, the AESOP Project Manager. The project brought together a consortium of 30 universities and research institutes across Europe and Australia, led by the Leibniz Institute for Astrophysics in Potsdam. The foremost science team includes more than 700 investigators worldwide. While many telescopes simply photograph the sky, foremost breaks down the light from each object into its component colours, a spectrum, revealing information invisible in ordinary images. Astronomical spectra work like cosmic footprints, revealing what an object is made of, how hot it is, and how fast it is moving through space. The European Space Agency has expanded its capability to communicate with scientific exploration and space safety missions across our solar system with the inauguration of a new 35-metre diameter deep space antenna, the fourth for S-Track, ESA's Deep Space Tracking Network. Located in New Norcia, about 115 kilometres north of Perth in Western Australia, the new Norcia 3 antenna will help meet the agency's fast increasing data download needs and secure Europe's independence and leadership in space. Started in 2021 and delivered on schedule, this construction is the result of the outstanding capabilities of ESA, European and Australian industry, and excellent cooperation with international Australian partners, ESA says. When the new deep space antenna enters service in 2026, it will support ESA's current flagship missions flown as part of the agency's scientific exploration and space safety fleets. That includes the missions of JUICE, Solar Orbiter, BP Colombo, Mars Express and Hera, and will be a crucial enabler for upcoming missions including Plato, Envision, Ariel, Ramses, and Vigil. ESA's fourth deep space antenna, the second one on the site at New Norcia, is the most technologically sophisticated antenna to date. It incorporates advanced deep space communication capabilities, including components cryogenically cooled to around minus 263 degrees Celsius. That's near absolute zero. This sensitivity allows it to detect extremely weak signals from distant spacecraft and to maximize data return. For transmission, a 20 kilowatt radio frequency amplifier enables transmission of commands to spacecraft millions and even billions of kilometres away from Earth. The antenna also features advanced clock and timing systems and world-class radio frequency communication tools and techniques to support deep space communication. Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week and the occasional science fiction podcast. Like, follow and subscribe for more. Membership available to help us do more. That's at thetrek.zone/support. Non-stop through Christmas and the new year. Here at the tail end of 2025, this is Talkin Science.